Hello guys, so today I'm gonna talk about improper integrations. Improper integration. It doesn't have the R. Okay, so many of you guys gonna ask like, why do you guys need to apply improper integrations? So there's two cases that you have to or you must do. You must apply improper integrations. So the case one is that the integrations has the infinity or negative infinity or infinity bound, or what I normally call is the range, which is just like negative infinity or positive infinity, or from some numbers to positive infinity, or from negative infinity to some numbers. Or case number two is that the area between the area of the functions between the given bound is infinity. What I mean so far is just like when you draw the functions inside the integration, it's gonna be look like this, or it's just gonna look like this, or something, and they asking you for calculate for this areas, which is infinity. You can see so far. So by that you have to use that limit from some numbers to infinities to calculate for it. What I mean so far is that I'm gonna explain to you right now. So for example, for case number one, that the infinity of 2 to infinity of 1 over square root of x dx. So you can see right here is just like the integrations with infinities, right, like this. So you cannot take like the real integrations, just like do it really truly outside. So by that you have to call limit from a to infinity. You can call this one a or b or c or d or some things. Just don't call it like x. Don't call it as x or y or z, because like it's just really common things and you just got confused between this one and this one. Okay, so limit from a to infinity of 1 square root integration of 1 to 2 to a square root x dx. After you take this integrations out, it's going to be equal with limit from a to infinity of 2 square root x of the range from 2 to a. Right now this integration is going to be from limit from a to infinity of from 2 to square root a, which is here. You just plug a right to here, minus with 2 square root 2. Okay, so this one, limit from a to infinity of 2 square root a minus 2 square root 2, this one is the constant. But this one gonna go to infinity, because 2 square root of infinity is just infinity. So infinity minus with the constant equal with infinity, so which means this one is infinity. Okay, so for the case number 2, that the functions, for example, the given function is gonna be from 2 to 3 of dy over y minus 3, or this one gonna be from 2 to 3 1 of my y minus 3 dy. just don't read things like, just don't go to Desmos and just grab the function of 1 like x equal 1 minus y or minus 3. Don't do it. Just you can just like x minus 3 and find out this one on Desmos. That is good enough. So you can, when you draw it on Desmos, or I just draw it right now, it's just like of the functions 1 over x minus 3 is gonna be like this. So you can see 0, 2, 2, 3. So you can see at a range from 2 to 3 is gonna go to infinity, because 3 make it go to infinities, and they've asked you to find out this areas. By that, you have to name it at limit, because 2 doesn't make the cost to go to infinity. That is the free one, which is when you, or you can just like 3 minus with y, it's just like 1 over 0 is just, when I normally call is black hole, like it's just go nowhere. Okay, so limit of b to 3. So for this integrations also I forgot, so you have to know like either it's gonna go from the left or from the right. The areas, is it gonna go to from the left or from the right? So from the left is from this side, and from the right is from this side. Okay, so this is the areas. It just came from negative infinity. Just run back to here from 2 to 3, which means it's gonna from the left. So it's gonna be 3 minus. Or normally you guys can think this way: if 3 on the top, or like if any numbers on the top, is gonna be on the left, and if some numbers in the bottom one is gonna from the right. So the numbers that caused the happening, if it is smaller than the range, the order bounds, then it will go from the right, and then if it is bigger than the order bound, then it will go from the left. So you can see I explained to you so far, it's just like 3 is causing these kind of problems. So, and also 3 is bigger than 2, so we use this conditions. So that is gonna be from the left, so 3 minus of the integrations of from 2 to b to 1 over y minus 3 dy. And then you can take your substitutions, so u equal with y minus 3 du equal with dy. So we have the limit from b to 3 minus of the integration of from 2 to b 1 over u du, which means limit of b to 3 minus of L length of u, absolute u, from the range, not a given range, sorry, after you plug back in, that is when you have a range. It is equal with limit of b to 3 minus of L length of y minus 3 of the range. Right now we have the range from 2 to b. Okay. I'm just gonna write right here. So it equal with limit is equal with limit of b go to 3 minus of L length of b minus 3 minus with L length of minus 1. And you can see limit from negative to 3, it just go to negative infinities. So which means this function is negative infinity. So this one we conclude at these diverge. Also, there's two things that I'm just gonna mention before we go. So the function is diverge when it's just gave some like negative infinity or positive infinities, and it's converge when it's just like giving you guys the answers, like the numbers like 0, 1, 2, 3 or 1/2 or something like that. And also I see a lot of problems like this, so you guys just write the limit at the first step and then just like, oh, I don't want to write it anymore, so just stop writing that step, like these steps. And I will tell you this, do not do it. You will not have any point for writing without writing any limit, because like that is the concept of doing these type problems. So if you fail in knowing the concept, then you just ruin everything. So just take your times. It doesn't take any times. It doesn't take much of the times for you to do it. Okay. So maybe the questions is gonna asking you for the range from 2 to 4 instead. How can you do? How can you do if they giving you like instead of like from 2 to 3, like this example, it's just gonna give you like from 2 to 4. And you know that like this is the areas that I want to calculate. This area plus this areas. I'm gonna erase the board. So how can you do it? Okay. So by that we have to take 2 limit and we have to split it by half. What I mean so far is just limit from a to 3 minus from a range from 2 to a of the integration 1 y minus 3 dy plus with limit b to 3 plus of the range from b to 4 of 1 to y minus 3 dy. This one, when you just get this one, we know so far it's just like negative infinity. This one I'm thinking is might be positive infinity, like the same ways that you do. But negative infinity plus with positive infinity is not going to 0. Don't ever think about it. It just you guys can conclude it like this one is diverge. That's all. You don't need to give the answers thoroughly. Got it? Okay, that's all. That is all for improper integrations. Thank you and have a great day.